Thanks for coming in 10 minutes late, class. Well, anyways, today we're going to learn about partial fraction decomposition.
Excuse me, can I go to the restroom?
I suppose so.
See ya!
Well, that was quite an exit.
Hey, how about I teach you partial fraction decomposition?
Well, I suppose that can be a useful strategy sometimes.
I got it. Hey, wake up. Pay attention. Here we have your original equation. And in order to do partial fraction decomposition, you're first going to want to take your denominator and factor it, like so. Then you take your new denominator, add them together, and replace the numerators with variables that we will then solve for. Your next step is find a common denominator by cross-multiplying. So now you have a, x minus 2, b, x plus 5 as your new numerators. You take your new numerators and set them equal to your original numerator from the original equation. So now you will have this equation here to solve for your variables. In order to solve for each variable, you shall substitute in for x. Here I substituted x equals 2 to eliminate a, because a times 0 is 0. So using that, you can eventually get to the answer of b equals 7. Your next step is to solve for a, and I used x equals negative 5 to get rid of the variable b. In this step, you will find that a equals negative 3. Once you get these two variables answered, you can plug them back into the original equation right here, a over x plus 5 plus b over x minus 2, to get negative 3 over x plus 5 plus 7 over x minus 2. Now with your new equation that is much more simple to integrate, you can simplify it even further by breaking it into 2, bringing your negative 3 out in front over here and your 7 out in front here, and then integrate to get this as your answer. Here are a couple examples of some special cases for partial fraction decomposition. In this case, if you have x squared as one of your factors in your denominator, you simply take your x squared factor as your denominator, and in your numerator you take variable times x plus another variable, and carry out normal partial fraction decomposition. In this case, if you have a quantity raised to a power in your denominator, you simply take a variable over your original quantity plus a different variable over that quantity squared, and continue this until you reach your variable over quantity to whatever power you have desired here.
That was actually 100% correct.
What, Sean?